Hello and welcome to the Tech Report Podcast. Tonight we are doing a very special edition of the podcast after this week's review of the Radeon R9 Fury X graphics card, which is based on the first big new GPU from AMD in, a couple of years almost. And we did the review this week. There's been a ton of discussion on the site. There's some interesting results that we want to talk about. And we've been collecting your questions about the product, about the review process, about the whole sort of GPU race. And we have on hand here not just us. Jeff Campman is our managing editor here, who is collating all the questions from the chat and the comments. And Jeff is going to kind of help coordinate stuff tonight. So welcome, Jeff.
Hey, guys.
And then we have a very special guest, my friend David Cantor, who is at Real World Tech and Microprocessor Report. And David is going to give us some insights, I think, on some of the architectural questions that we may have about the Radeon Fury now that we've seen its performance. So thanks for joining us, David.
Yeah, great to be back. It's been a while since I've seen you, right? Almost a week?
Almost a week, yeah. So we were together at the launch event for the R9 Fury X, and at that time we were all speculating and we didn't have any performance data. And now we are infinitely wiser than we were a week ago because we spent some time testing the product and we can see what it's like. And so I think there's a good post-mortem to be done on what we thought we were going to see versus what we actually have seen now and what it means. So that should be good. So if you guys are watching the stream and you have questions, get them in. We'll take questions from the chat as we go. And I think the first thing that we probably want to do, guys, is just summarize briefly the results from our review. So we talked last week on the stream about the architecture of this chip. It's basically a scaled-up version of AMD's GCN graphics architecture with some sort of chip-level voltage and power savings, and a few tweaks here and there architecturally, some novel things. But it's kind of 2x Tonga, I guess, is probably the best architectural analog, don't you think, David?
Yeah. I mean, and that was one of the things that I found actually a little surprising about a lot of the coverage, is that people keep on comparing it to Hawaii, which, maybe that's true from a positioning and high-end GPU standpoint, but I think it's a much better analog to think of it as, 2x Tonga with HBM.
Right. And HBM is high bandwidth memory is the signature innovation in this product. 512 gigabytes per second of bandwidth, substantially more than any other graphics product, single GPU graphics product that we know. And, one of the interesting things about this is bandwidth is a significant bottleneck in graphics, but it isn't something that you just have more of and you get more performance. There are some balance issues. And so I think we'll talk about how the HBM's mega bandwidth fits into the larger picture as we go along. But those are the things that make the Radeon R9 Fury X interesting, and the obvious target for this product was to compete with the GeForce GTX 980 Ti. AMD priced this thing at $650, which is directly opposite the 980 Ti. That is NVIDIA's, essentially their high-end card. They have a Titan X based on the same chip with about the same performance and more memory, but for all intents and purposes, the $650 cards are kind of the high-ends for both companies, and that's the matchup that everybody wanted to see. And I believe last week when we talked about this, we had performance numbers from AMD showing the Fury X beating the 980 Ti in every benchmark game that they showed us. And now we've tested it, and the results that we've seen are a little bit different than maybe the expectations that they set for us. So let me pull up the review here, and we'll talk a little bit about a couple things. One of them is the GTX 980 Ti is interesting because due to HBM, due to high bandwidth memory being a compact footprint, where the memory is on a interposer, which is a shared silicon die with the GPU, the Radeon Fury cards can be much smaller than prior high-end graphics cards. And so what AMD has done in that context is they actually put a water cooler with the radiator onto the card, and there is it's really like a 7.7 inch card, relatively short for a high-end GPU, and then it has a separate radiator where the heat gets pushed out through that to the outside world, outside of your case. That makes this product exceptionally well cooled. It's a 500 watt peak capable radiator, and it also makes it just a very different form factor from anything else we've seen. This could fit into a relatively small form factor PC that doesn't hold longer graphics cards, but you're going to have room for that radiator to fit in. It's 120 millimeter emplacement, and if you already, like in my case, in my computer, I already have a CPU cooler that's a all-in-one water cooler, and I don't know if there's enough room. I'd have to really kind of see it, maybe a tight fit to put two of these things in at the same time. So that's kind of the physicals of the product, and it makes it interesting. The Fury X also is a 275 watt card. It has two 8-pin power inputs, which is just a little bit more than the 250 watt peak of the GeForce GTX 980 Ti. It is similar in power consumption to the competing GeForce, and AMD's Radeons generally lately have been higher consumption at the same performance level, so there's some goodness here with regard to all of that. So I think that kind of sets up what the product is. We've got to look at all the physicals there. I think someone asked, last week on the stream, asked what brand of fan was in the radiator. You can see I put a picture in the review for you. This is a Nidec fan. So I believe that was what they were hoping for. So I think you got what you wanted. The card has some LED lighting that serves as a tachometer for the GPU activity, and you can change that from red to blue or to red and blue, or you can turn it off if you want. And it has a glowing Radeon, which is actually that stoplight red, but I couldn't get any camera to take a picture of it where it looks stoplight red for camera-related reasons. So I may need I don't know what I need to get that true color shot there, but it looks to the eyes like... Jeff's going to tell me because he's a photography guy. What do I need? I need a polarizer, some of my white balance.
Red is just a really hard color for digital cameras to capture.
Well, I get some red. Like when I'm looking at it, the LEDs, or the tack, look the same as the red on the Radeon, right? When I'm looking at it with my eyes, and when I point a camera at it, it's like, oh crap! Look at that orange.
I don't know what's up there.
Okay. Well, maybe
I would have to play with it. But
to send you a card, and maybe you can solve that problem for us.
That would be awesome.
Anyway, here's a shot. If you're looking at the live stream, we've got a shot of the GTX 980 Ti, the longer card, next to the Fury X card. And these Fury X cards are basically all going to be the same. The R9 Fury, which is coming next month, middle of next month, will be $550, $100 less, and there will be custom versions that some air cooled, some water cooled, etc. But these cards, the Fury X's, AMD has controlled them, and basically there will not be higher clock versions that the companies will be able to sell. There will not be custom cooling. They basically have taken control and said this is the product for this high-end part, which I think is probably good in a sense. They want to impose some controls just to have a good quality product. They generally have done a good job with the physicals of the card and all of that. But guys, I do want to look at one caveat. David, did you read in the review there's actually an issue that I didn't realize what it was with when I heard it, but apparently it's the water cooler?
Yeah, I heard it was a pump issue is what it sounded like. Yeah,
when you turn on the card, whether it's at idle or running full speed, there's just this constant high-pitched whine that is so high-pitched it's almost like more when I was a younger person, I could hear it. I could go into a room and hear whether or not a CRT display was on. That's not something that, like, as you get older, you lose the sensitivity to that sort of ultrasonic type stuff. I can hear it, but it's a very high pitched sound that reminds me of that coming out of the card when it's on all the time. And I thought maybe it was coil whine or something like that, but it's not related to activity at all. It's not coming from the pump. Sorry, not the pump. The fans. It's coming from the area near the pump. And what AMD said when we asked about it, they gave us a statement, and they said that the high-pitched whine is actually the high-speed pump. And they said, well, it's worse because you're testing on open test bench. If it was in a case, you wouldn't notice. And all of them do this and stuff. I have multiple. I tested the R9 295X2, which has a water cooler. I've got a water cooler on my X99 CPU test rig that's on an open bench. I've never heard a water cooler emit this amount of high-pitched whine. It doesn't show up on a decibel meter, but it's enough to really be annoying. And it never stops. And so I'm not sure about the way that they kind of contextualize this, like it's not a big deal.
I mean, I thought they said that was fixed in like the final production versions.
They did. They said this issue is limited to a very small batch of initial production samples, and we have worked with the manufacturer to improve the acoustic profile of the pump. This problem has been resolved, and a fix added to production parts, and is not an issue. So there is a statement from AMD that in no uncertain terms says it's fixed. The issue here is that we have not been able to verify that, and I would really like to. And so if you're a reader or listener here and you bought one of these things and you've got it, let us know whether or not you hear pump whine. We've asked AMD, we requested to get a production card. The issue with this is this. We got our Fury X test card less than a week before the product launch. The product's now selling at Newegg and Amazon. In fact, I think they sold out like first day.
Yeah, they're all sold out.
The people who bought those, it seems very unlikely they got a product that's significantly different from the one I tested. So I don't know. I don't have a lot of insight into the timing of all of that, and we have to take their statement at face value. But it doesn't seem like there's a lot of time to make production adjustments and then ship out new product and get it into stores. So I'm a little concerned about that. But hopefully, like they nailed it on the water cooler. One of the best things about this is I think they have a little bit of competitive advantage here. And I'm going to give away the game here a little bit on our test results. But what we found in terms of noise levels is that the water cooler under load is substantially quieter than, let me find this, than anything else that we measured. And it also maintains very low GPU temperatures around 52 degrees Celsius, which is what AMD said the tuning target was for the power tune algorithm that controls this thing. And so they beat virtually everything in this regard. And I think the rationale makes a lot of sense. If you're spending $650 for a graphics card, then I think you'd at least want this type of excellent cooling that sends the heat right out of the case and does it quietly and very effectively to be an option, right? So, so they're competing with an NVIDIA card that has a conventional blower, but they're providing a superior cooling solution for the same price. Seems like a win. Not everybody's going to want it, maybe, but I like what they did. So,
yeah, I mean, I think it's an overall nice touch, right? I mean, and it sort of, you know, I remember when Lisa Su was talking about how they want to do products that feel like and are premium products. And, you know, certainly I think the attention to detail, well, you can say, oh, you know, it's a waste of money because it's inside the case. It's true, but it does look like a high-end premium product.
Right. And it's I mean, there are tangible, audible benefits to this thing. And also, if you're building a system, a cooler that takes all the heat very effectively, takes it out of your case, is a big deal for the quietness and the cooling of the entire system. So it's a good benefit to have. And as long as you are comfortable with, I've got room in my case for this 120 millimeter radiator to be mounted, then I think it's what you want. But they have to make sure the noise is right. So that's an issue.
I'm pretty sure they'll get that fixed. I mean, that seems like a straightforward mechanical thing that can probably be swapped out.
Yeah, one would hope. You know, there are a couple reasons why it makes sense for them to do this cooler beyond just, okay, it's neat. And one of them is keeping that 52. We talked about this before. I think keeping that 52 degrees temperature on the GPU reduces leakage, reduces the voltage required to run it, makes it more power efficient. So they're better off in terms of power efficiency by just suppressing the heat all the time. And the interesting question about the Fury cards that are coming later, some of which are air-cooled, is how does that picture change when you don't have 52-degree constant cooling? And that's assuming that they won't have like super mega air coolers that do the same thing. We may see that. And the other reason that you want to have...
I bet you could probably talk to NVIDIA and try to get some of the old NV30 coolers for that.
Oh, the FX... Yeah, the FX 5800 Ultras with the hair dryers.
Yeah.
Yeah, that would be... I don't know how effective a cooler it is, but it's certainly loud. So, yeah, that would do it. The other reason that you want to keep your GPU cool all the time is completely slipping my mind now.
Just lifespan and aging, right?
Well, there was another thing that I said in the review that now it's been a long
leakage current, right? With
we already
Fury
said
X?
leakage,
Oh, okay.
so
yeah.
But there was another thing that I'm completely
you
failing.
Probably knock off somewhere between like 10 and 20 watts of leakage power with.
Well, here's the other thing. I've thought of it. The other thing is power density. The water cooler is good at pulling power away, and with Radeon Fury, they have a very big chip that consumes a lot of power, and then around it they have the HBM memory too, and it's all very compact. And they had some trouble with the Hawaii chip, which is actually a smaller chip than this, lower power, similar power consumption, but they had some trouble with the stock coolers not keeping the cards cool enough that they would run at constant speed. And the review cards did better than the retail cards, if you recall. And they kind of fixed that by going to aftermarket coolers that were bigger and beefier. That was kind of, that product became, don't buy the reference card. And by doing water cooling, I think they can deal with some of the power density issues a little bit better. And so I think that's another reason why we have water cooling here. So anyway, let's talk about performance, because that's what everybody wanted to know about this thing. And I'm going to pull up, let's go up to just one of the games. Let's take a look. We got Project Cars results here. And if you guys are familiar with the way that we test, we do the frames per second thing that everybody else does, but we also record every frame of animation that comes out of each game. We record the time that it takes to produce that. And doing so allows us to not just measure sort of potential, which is what FPS does, but also delivered performance, because the shape of a frame time plot, as you can see here, can be very hairy, and it's not the case that PC graphics cards produce a nice smooth progression of frames from one to the next like FPS seems to suggest. It turns out that it's a very hard problem to produce animation in a real-time system and consistently produce low frame times. And so we try to quantify performance by looking at the whole frame time distribution and doing some smart analysis on just the question of, are we keeping frame times low generally, and are we avoiding big spikes that would cause slowdowns in animation? Because the way that FPS tends to be presented, you're averaging over a second. And in the span of 1 second, you could have a 40 FPS result that is just a series of frames that are about the same time each, or you could have a bunch of really fast frames and then one like super long frame time where you had a hiccup and things are slow. The qualitative difference between those as a user is huge, but the quantitative difference with just an FPS average is nil. And so it masks potential problems. So we're trying to do a better job of quantifying gaming performance. And this is something that, as I test, I'm playing the game as we capture these results, and I'm taking notes about this is how smoothly this card played this game, and then we can kind of correlate our experience to the frame time plots and the other things that we have. So that's very complicated stuff, but the simple thing is just how well does it play games. And in the case of some of these things, the like Project Cars, the FPS average and the frame time centric 99th percentile frame time metric that we use tend to agree. And what I found playing Project Cars on the R9 Fury X, this is almost all in 4K. We did most of our testing there because honestly, when you buy a $650 graphics card of this class, you get its full potential by playing either in a 4K resolution or with something like dynamic super resolution, or the equivalent VSR on AMD, where you internally render at really high resolution and then render down to a lower target display res, because otherwise really you're generally okay with a less expensive card. There are exceptions here and there, but That's my take. So we concentrated on 4K. I think that also is the Fury X's strength. And what we found is in this particular game that the Fury X was a little bit slower than the GeForce GTX 980 and substantially slower than the 980 Ti. It played the game smoothly at 4K. It's a good product and is a big advance over the Radeon R9 290X. But it is not, David, what we saw in the benchmarks from AMD, where every single one of them, there was a small to large, depending on the game, advantage in favor of the Fury X. It turns out that this is part of a general picture in which the R9 Fury X tends to be slower than the GeForce GTX 980 Ti. And I'm just going to skip now that we've done that work. I'm not going to go through every game, but I'm going to skip now to the end here, and let's talk about our scatter plot. And the scatter plot gives us price and performance. The Fury X and the 980 Ti had the same basic list price, so there's a slight gap in performance. We're talking about like somewhere on the order of 8%. It's under 10%, or about 4 frames per second, the way that we do our overall average, that the Fury X trails the GeForce GTX 980 Ti. That is with slightly more power consumption from the Fury X.
But a lot less noise.
Yeah, so it's a pretty good picture from that standpoint. The trick, though, is, as we often do, we always do, we tested the 99th percentile frame time, which is a measure of general performance in games, not just like, okay, here's the GPU rendering capability and potential, but here's what it does in the game generally, and it kind of includes up to the last percent of outlier frames that maybe are really hard to render. We'll rule those out, but the 99% of frames are rendered in this, so under this threshold. And what we found is that the Fury X suffered a lot there. Not because of results like we saw in Project Cars, but in other games especially, there were spikes in the frame times throughout the test run. There especially were instances like in Crysis 3 where there's an explosion on the screen during the test run, and there's a lot of particle effects and a lot of things are happening. And when that happens, then you get these spikes, you get these high frame times, you get these delays that you can feel as you play the game where the animation is interrupted. As a result, in our frame time centric metric, the R9 Fury X actually performs not as well as the GeForce GTX 980, which is a GM204 based card that costs $500, and it's substantially slower than the GeForce GTX 980 Ti, which is its competition at $650. So that is unfortunate. It is also something that we have has been a fairly consistent feature of the graphics comparisons that we've done for a little while. And I think the only good news here about this is that, David, we don't know for sure how much of the way that this like delivered performance disparity breaks down, but it's quite likely that a fair amount of it has to do with actually software and not hardware. That has to do with the graphics drivers and the per game optimizations that AMD and NVIDIA both do. And it appears that basically NVIDIA is better at this than AMD, and in a way that we can quantify that is basically a larger effect than the overall potential measured by FPS.
Yeah, and I mean, that's not surprising, right? I mean, you know, everyone's known for a long time that NVIDIA has a much more aggressive, you know, both driver team, but also, you know, their ISV tuning is a lot more pervasive.
Yeah, and you know, we know that AMD has had a lot of layoffs and challenges in recent years, and this is hard work. But, you know, it's tough because they build good hardware here. It's not quite as fast as the competition. HBM is a substantial advance. They have new technology. We kind of hope, and we'll talk about this, we kind of hope that HBM would lead to something like competitive advantage, right? I think AMD hoped that at least. And instead we have something closer to parity on like measured GPU capability. And we can go through the architectural measurements that we did. But, you know, those look good. There are differences between where the strengths are on the different chips, but those look good. But when it comes to how does it play a game, that's where the rubber meets the road. And unfortunately right now, the AMD product just isn't as good. And can they fix it? Yes. Will they fix it? I don't know. How soon will they fix it? It's been a long time since we've seen them really be competitive on this front, and I think it's a hard thing to do. So I don't know what you do in this situation if you're us, other than just show people the numbers, show them the results, and let them make a decision. I'm a little bit surprised, though. Most of the other people around the web who have done reviews of this thing have looked only at FPS or have not considered the meaning of the frame time data if they do collect it. Some people have listened to what we've done and started doing that. But the meaning of this data is plainly is that you're better off if you want to play games in 4K with a $150 cheaper NVIDIA card than with the Fury X. And I think that's a disappointment. And I don't want to be. Don't shoot the messenger, please. Like I don't want this to be true. But it is the case that there's a difference between FPS averages and the potential they represent and what happens in a game. And we're trying to highlight both. So there you go. That's a summary of the review overall, I think. Guys, did I miss anything important about what we learned about the card?
No, I don't think so. I think that pretty much covers the main takeaways. So,
I think what we have next to do is we have a ton of questions from the chat.
Yeah, we have a lot,
and so we can. David, you and I can kind of tag team on these, I guess, as appropriate. Yeah. If they're sure. review centric, I'll take them. If they're architecture related, I may have to hand off to you, or I may want to hand off to you to get your perspective too. So let's just see what we can do about tackling these questions. And then there's an interesting set of architectural questions that I want to get into with you, David, after we've done that.
Okay. So Riss asks, I'd like to know how Scott and David feel about the balance of Fiji and whether it should have been so focused on being so wide. And someone asked a similar question. Power666 asks, should they have added more ROPs instead and scaled down shader count? So I'll open the floor to you guys.
Well, that goes straight into our architecture discussion for later. And now we're totally, our plan is screwed up. But that's great. So let's do this real quick. David, I'll give a summary of what we've found, because we had the results, we had the numbers. And so we said last week when I wrote my little architectural piece, there's a very clear disparity between the Fury X strengths and the 980 Ti's strengths. And the Fury X is unusual for a new GPU because it's scaled up in some respects compared to the R9 290X, and in some respects it's not. And we're comparing to the R9 290X because that is the closest analog among big GPUs that we could test at 4K, David. The R9 285 is not really a good candidate for 4K testing, and it's not anywhere close to the scale of this thing. But it is true that there are some elements of the Fury X that are refreshed from the R9 290X, so we can't get too infatuated with the numbers in the table. Instead, we really want to look at the results that we have. But what we found generally is that the numbers in the table and the results track pretty well, which means that this GPU manages the theoretical peaks that it has on paper when you measure the directed test of a certain part of the architecture quite nicely. And the Maxwell-based GPUs from NVIDIA tend to do the same. And some of that's down to Riss's tools, the Beyond 3D tools that we have, actually extracting all of the parallelism and all the performance out of these chips in an effective way so that we have good measurement of the architectural peak rate. So this is cool stuff. Compared to the 290X, the Hawaii chip, the Fury X has no more render backends or ROPs. That's the same thing, different terminology at different companies. So it has the same peak pixel fill rate, has the same basic multi-sampling, anti-aliasing blending capability, the same Z and stencil for shadowing and things like that. So essentially, there's not been an increase in terms of those resources. Now, there is a color compression facility built into the Tonga chips and now into Fiji that will allow this GPU to more effectively store or stream data out of those ROPs. And so there's a potential for faster throughput overall. But the ROP count has not gone up. And the big deal about that is that the ROP count actually in the GM204, which is the smaller NVIDIA chip, is higher than in Fiji. And the ROP count in the GM200, which is the big NVIDIA chip, is like a third higher than in Fiji. Now, these are not the same hardware. It's NVIDIA's ROPs versus AMD's, but there's a disparity there.
Yeah, I mean, I think one of the interesting questions is, and I don't know if you did testing at different resolutions, Scott, but certainly if you see the performance delta change and decrease at higher resolution, so if AMD is ahead by more relative to NVIDIA at, say, 4K versus, 2.5 but times 1.4, that would actually be an indication that the ROPs may not be the issue, right?
Okay.
Because, the key for the ROPs is, how many pixels are we going to be shooting out? And, if the issue is, if it's really fine for 4K and the picture at 4K looks better than at a lower resolution, then that's an indicator that it might not necessarily be the ROPs and might sit somewhere else in the pipeline.
Right, and I want to get into that, but let me finish setting this up. I should have gone ahead. Yeah. So what they did scale up in Fiji compared to Hawaii, and what is one of the huge strengths is the shader arithmetic, the big old shader array, and that also goes back to the texturing, which is mated to that. So this thing can access memory through textures, filter textures, and has a big 8.6 teraflop shader array, 4096 stream processors or shader ALU lanes, and that is substantially more than anything else. The peak rate on the GeForce GTX 980 Ti, 6.1 teraflops. Peak rate on this, 8.6. Similarly, the memory bandwidth, which we talked about with HBM, 512 gigabytes per second for this. The 980 Ti is 336 gigabytes per second. So what we have is we have a lot more texturing power than the Hawaii chip. Depending on what texture format, it's faster than or just a little slower than the 980 Ti on texturing. We have a peak shader arithmetic rate that's substantially higher. We have more memory bandwidth, but we have a lower ROP rate, or no higher than the 290X, lower ROP rate than the NVIDIA. And then they also didn't make any substantial changes to the rasterization rate. They did tweak that hardware a little bit, they said, to get higher throughput. And they did some of that in Tonga. Not clear on how much more of it they did, but I think they did do more in Fiji. But on paper, the rasterization rate is exactly the same as the 290X, and it's again like a third less than the NVIDIA. And that was one of the things we measured. We measured the pixel fill rate, and the numbers that we saw on the table are right. Compared to the 980 Ti, it's almost a third less pixel fill rate. We measured bandwidth, and that got to be complicated. I'm not going to talk about that right now. That's a test-related thing. Texture filtering, there's a ton of it on Fiji. And polygon throughput, though, when we get to that, then we actually have somewhere on the order of about half, maybe a little more than half, and it depends on the format of polygons, and it depends on whether tessellation is in play, but substantially less throughput than the competing NVIDIA chips. For games that use a lot of polygons or tessellation or have a lot of effects on screen, there's the potential for that to be a downfall of this architecture. It's also the case that this thing can push a ton of polys, and the question about whether or not that's a real problem goes back to the way that game developers use these chips and whether or not they really put enough polygons on screen for that to be a problem. Generally speaking, historically, that hasn't been an issue, but the requirements of new games change all the time. I will say this. Many games are ported from consoles, and the consoles are not as capable as any of these cards. So the assets and things like that people generate for console games, they're not going to tax this GPU on that front. So, you know.
Although, I mean, the other point about that is worth considering, and this is a point that was made to me by Timothy Lotz, is that, you know, the consoles seem to be able to play, you know, at least some of them can play 1080p fine. You know, well, what's the difference between a console and a PC? And of course, the answer is the API, right? That is the biggest difference.
Right.
And so, you know, to some extent, I wonder how much of this is a reflection of, like, cruft in the driver, right? Because, you know, if you were to use one of these close to the metal low-level APIs, you really step around a lot of the driver overhead.
Right.
And maybe that is an issue for AMD. I mean, it's hard to say.
Well, you know, you see things like this difference between the polygon throughput when you have a list versus a strip format, which is not existent on the NVIDIA hardware, and you have to wonder if that isn't something like a driver issue. It could be architectural. It could be that there's a clear preference in the architecture for its data being formatted a certain way, but I don't know, man. I don't know about that. The last bit of information that we have about the balance of things is just a confirmation that 8.6 teraflop shader array is for real. I don't think there's any question that thing is very impressive. And so the question is, and let's go ahead and do this because everybody wants us to do this, David. Why, when you have so much more shader power, so much more texturing capability, so much more than anything, memory bandwidth, right? Why are you not beating the competition outright, at least in like multiple games, if not, you know, in everything? Like, why isn't this a closer race?
Yeah, I mean, so, you know, it's funny because a priori, I was really expecting that AMD would trounce NVIDIA. And, you know, you've got the cooling, which draws down your leakage current, which means you get more power for everything else. You've got the HBM, which is probably saving you another 10 to 20 watts. I mean, like, there's, you know, AMD is coming into this with a huge number of advantages. And so, you know, I think ultimately you have to look at the architecture. And it's a little tricky. I haven't profiled games recently, but I think geometry is definitely, you know, a weak point for AMD. And then the other thing that, you know, Riss pointed out when I was talking to him, and this has been true for a while, is the Maxwell architecture is really tuned for graphics at the expense of compute to a certain extent.
Sure it is. Yeah, they're not even selling that into the Teslas. Yeah.
Right, exactly. And so, you know, I think one of the issues is that the GCN architecture is really much more general purpose. It's not, you know, they can specialize a bit, but the other thing is, you know, the fundamental SIMD width is 64 for AMD, right? A wavefront is 64 data elements, whereas a warp for NVIDIA is 32. And so, you know, if this is one of those questions where you've got to ask yourself, well, how wide are the pixel shaders really? How wide are the vertex shaders? And can you really make good use of that? Or are you having to you know, run a bunch of lanes that are empty? Because in that scenario, you might be happier with the narrower organization of NVIDIA GPUs. So that's one aspect. You know, you touched on the geometry. The filtering is actually a pretty big delta in the Beyond 3D suite. You know, I think it was, you know, if you look at the 980 Ti, it's like 185 gigapixels per second versus for FP16 versus 134 for the Fury X. So, you know, that's another thing that I would look at. And there was someone on my forums who pointed out, you know, accurately that it's actually, his opinion was that the most likely culprit was either geometry or the texturing. And one way to do that would be to test at multiple different resolutions, right? Yeah. And as you get to these high resolutions, you'll be more ROP bound. As you, at a low resolution, you're going to be an awful lot more triangle bound.
Okay, well, let's talk about that for a minute, because I, unfortunately, just as a matter of, like, I'm trying to do this real-world game testing stuff, I can't test at 12 different resolutions.
Right.
With the unscripted, I sit there and play the game and take notes, and we capture every frame and analyze it approach. And I probably need to add some automated tests that are based on games to our suite so that we have some resolution scaling data. However, I do get back channels open from other reviewers who want to know why this thing doesn't perform like one would kind of hope. And we had a lot of that this time, and a lot of them shared their data with me before the launch, and they basically said that in terms of relative strength, the Fury X got better the higher the resolution. So we tested primarily at 4K. We were showing its strongest hand when we did that. And what they found is that it's closer to the performance of an R9 290X at lower resolutions. And then it kind of comes into its own as the resolution goes up. There's another data point for you, because I know that's interesting, right? So here's the other data point. Is you guys remember that AMD had some reviewer's guide benchmarks that got leaked last week. It was the first time anyone saw any performance data from the
that was
Fury X.
a mess.
And those results showed very nicely that, the Fury X won in every game that they gave us results for. But I looked at them a little more closely after I had some of my own results, because my testing was varied in terms of the settings and anti-aliasing and things, but it was kind of tweaked and tuned like a gamer would want to tweak and tune, right? You kind of turn up the quality in the game as much as you can without hurting performance. You do the right thing with regard to anti-aliasing, which in some cases is multi-sampling, in some cases is procedural, like SMAA, FXA. In some cases it's a little of both, right? And you go for something that's playable at 4K that still looks good. What they did in a lot of, not everything, but in a lot of the games they tested, and I wish I could bring up this document, but it's kind of a pain to do it here, is that a lot of the games they tested, they set the texture filtering to 0x anisotropic filtering, which as a gamer I would never, ever do. Like, the biggest visual quality optimization that you can make is to turn anisotropic filtering to 8 or 16x. It's awesome, and it's fundamental, and you want that, right? And they turned that off. They turned up the quality level on every single shader effect, or almost every single shader effect, the quality of the texturing, or not quite texturing, I'm sorry, the quality of the shadowing and the lighting and the post-process effects. And in most cases, they did not use multi-sampled anti-aliasing, but they use things like SMAA or FXAA, which are done in the shader array that are post-process. And that was how they tested in order to get results that showed, and it was all at 4K, and those results showed the Fury beating the GeForce GTX 980 Ti. So, David, from my point of view, I look at those results, I'm like, they're playing to their strengths. 8.6 teraflop shader array.
Yep.
Don't stress the texturing. Don't stress the ROPs. Just do everything you can, as much as you possibly can. Tailor that workload to use the shader array and compare to your competition, whose 6.1 teraflop shader array isn't going to be as good, and take the other things out of the game. And that's how they got to their numbers. So that gives us some additional insight into the architecture, I think, from the standpoint of what are the strengths, right? Probably not texturing, probably not ROPs.
Yeah, I mean, I'd agree with that. Although the other thing, so there's two aspects of that. And like you touched on one, which is, well, what's the actual physical resource you're using, right? And this is great because it means, for AMD, it means instead of having to do your multi-sampling passes at the end in the ROPs, you're going to run it through the shader where it's cached nicely, hopefully. And that's great. And then, on the texturing, right, you're obviously avoiding texturing bottlenecks in the context of FP16.
16-bit texture formats, int or FP, whatever you're doing.
Yeah, whatever it is.
Those happen at half the rate of 8-bit texture formats on the GCN stuff, and they happen at full rate on the NVIDIA stuff. And so if you look at the GCN's texturing capability, the Fury X texturing capability for 8-bit formats, 8-bit per pixel, or 8-bit per pixel formats, it is the world beater. It's the best in the world. But when you look at 16-bit, which some games, they use a mix of formats, but some games may use more of the 16-bit stuff now. And I don't actually have, well, we should probably get some data on that. I think you could break it down with the tool and see. But to the extent that 16-bit texturing is used, then you have a competitive disadvantage for the Fury X. Not a massive one, right? That's the thing about these numbers. It's not a massive one in terms of what we measured, but it is pronounced, right?
It's probably like 30% delta, right?
But eyeballing it there, it looks like 25 to me. So
yeah, I mean that's essentially the same thing.
Yeah.
But,
for architecture, it's the same. Right.
You know, horseshoes and hand grenades, right?
Right.
No, I mean, but there's another subtle point in here, which is that, you know, one of the strengths of GCN, which is, again, something I didn't appreciate initially in some ways, is the control processor, right? And the way the work is distributed and the fact that you have these 8 independent queues that can dispatch compute work, right? These ACEs,
right,
that
for
can dispatch
compute
into the shader array. And so by taking things that were previously graphics work and then making that into a compute shader, you know, that actually allows things like asynchronous compute shading to take advantage, and that really does just generally play to the strengths of the architecture. And so, you know, on one hand, it's interesting because, you know, in a lot of conversations I've had, people are saying, yeah, this is the way of the future, right? The future is not doing multi-sample anti-aliasing like 8x because it blows up your bandwidth too much, right? It's just not effective, and you really want more intelligent anti-aliasing techniques. But, you know, this is, you know, there's sort of an issue here, and this reminds me a little bit of the Pentium 4 in some ways, in that, you know, there's a trade-off between skating to where the puck will be and skating to where the puck is. Right. And today, the issue is, you know, we've got, I mean, there's still people playing DX9 games, right, and benchmarking with it, like Skyrim, for example.
Yeah. Right.
I definitely saw a bunch of other reviewers using Skyrim. And there's nothing wrong with that. It's a great game, and, you know, it's important that it looks good. I mean, it's a gorgeous game.
Yeah.
But, you know, that is certainly not something that's going to play to the strengths of the Fury. On the other hand, my guess is for something like Skyrim, you know, it really doesn't matter whether you've got a Fury X, a 290X, you know, or whatever. You're probably well above the saturation threshold even at 4K on that.
Yeah. I guess there's another relevant point to be made in this context, which is if you look at just the FPS difference between this and the 980 Ti, imagine that through software driver work, AMD was able to deliver frame times and delivered game performance that was as good as or better than what NVIDIA does. And they had a little bit of a deficit in terms of overall FPS in current games. It wouldn't hurt that much to have an architecture that was forward-leaning, where that big shader array wasn't always completely used by current games, right? It hurts because the current situation is that big shader array is there, and we're not seeing a payoff in terms of delivered performance for the end user, which is different from the question of why is this 8% slower in FPS overall, right? And so that's probably worth mentioning in this context.
Yeah, I mean, I definitely see the latency being the big issue. You know, in my mind, for a lot of this stuff, if you're within 10% on performance, you know, it's basically a wash. Because right there, it's going to come down to really what games are you as a gamer going to play and buy. And hopefully buy and play. And, you know, the challenge is that I think AMD has been much, you know, it's interesting because folks like Raja really get the message, and they you know, when you talk to them about frame latency, they get it, and you're preaching to the choir. But then one of the things that I just found really frustrating about that, you know, reviewer's guide is it's measuring performance in terms of frames per second. And it's like, it's tough for me to come away with the perception that everyone at AMD knows what's going on because the left hand isn't talking to the right hand, right? If I talk to Leila Ma or to Raja, they will talk about latency. Similarly, you talk to Andrew Lauritsen at Intel. It's always latency, never FPS.
Right.
But then you get these documents where it's like, why are you talking in terms of FPS? Like, we know this is not the best metric.
Yeah.
And, I think one of the things that would just be great for AMD is if they could strike FPS from their vocabulary and just only talk about things in terms of latency.
Yeah,
just internally.
One thing that is happening is everybody has to readjust for virtual reality because all of a sudden, like, your literal, like, the latency loop between when you move your head and when you get the visual feedback needs to be very, very, very short. And you can't mess up on that or people are going to blow chunks, right? So you have to deliver.
Yeah, I mean,
you have to think about animation as a real-time system and as janky, hiccupy experiences as a failure. It's not okay anymore because we understand now that it messes with the human visual system. It always has. It's never been good to do that, but there's been a perception that you can get away with that on a fixed display, and it's very clear that in virtual reality you cannot. And there's a lot of work going into that. And you know what they're using in virtual reality is they use the Liquid VR APIs that AMD provided that use those ACE engines to make sure the work gets scheduled well, and then they preempt stuff even, make sure that like the next frame must get out on time. And and there's really good innovative work being done there by people like John Carmack at Oculus, and then the people cooperating at the graphics companies. And the hope is that this will spill over into every fixed display gaming, which frankly it should all be the same. Like this should be the goal all the time. And so one would hope that we'll see that happen.
I mean, I think AMD, and that's the interesting thing, right? I mean, they've invested a lot in their Liquid VR SDK, and I think they definitely care, and they're not just thinking about it in terms of video only, but also in terms of audio, which is, if you think that the human visual system is sensitive to jitter, right? The audio system, right? Our ears are just way more sensitive. I mean, you can have a video that gets like a little blurry and a little crappy and you're kind of okay with it. But if anything janky goes on with sound, I mean, you will pick up on that super quick. And I mean, the other thing is, to your point, when we were in LA, I tried out a bunch of VR demos with AMD, and I the Eve Valkyrie one was spectacular. I mean, that was just like, it took advantage of the stereo, it took advantage of the VR experience, and it was great, and it was intuitive, too. And then there was like this army cartoon one that I played, and there I got like so nauseous from that I was unable to eat for an hour or two.
Oh.
Which, right, that's me, so that's really saying something.
I was going to say, that must have been when you disappeared for a while during the afternoon when I was giving Richard Huddy a hard time about stuff. So I missed out, but I played Eve Valkyrie, and here was my experience. Just because there's so much goodness here, right? Eve Valkyrie, they had it was Crescent Bay, which is the latest prototype, not the prototype of the consumer version of the Oculus, but the last prototype prior to the consumer version that AMD had hooked up to a Fury X card. For these VR demos, and the Eve Valkyrie guys were there, and they had the latest build of the game, and this is sort of my experience was in contrast to last October at the GTX 980 launch. NVIDIA had Eve Valkyrie hooked up to this same model of headset on a GTX 980 card, and I think a lot of this progress is software. I don't know how much of it is the difference between where NVIDIA is now, where AMD is now. A lot of time has passed. But when I played in October, I couldn't track bad guys as you're moving your head around in the cockpit and looking for them in this 3D scrum of stuff flying everywhere without losing them. And then I just get blown out of the sky. When I played the other day, well, first of all, one of the first things I noticed was they had proper edge anti-aliasing on that and every other demo, and it seemed like it looked like the effective resolution was higher as a result. That was beautiful. And so
yeah.
we're getting polished because we're ready to get to the end of the road on VR and actually launch with consumers.
But
and so they did that.
Back to our previous discussion, though.
Well, let me tell you let me tell you how this went. So, David, the other thing I did was I tracked the bad guys in 3D space the whole time and shot them down and knew what was going on, and I didn't get disoriented. The sense of presence was so much better that I didn't lose my bearings, and that was progress. And so anyway, I just wanted to get that out there as like these things have gotten better, and it's precisely because they're targeting the right things.
Yeah, but I mean the point about the edge anti-aliasing is, do you think that's done in a compute shader?
It could be. It entirely could be. I mean, there's no reason when you're doing post-process AA, I think most post-process AA, like FXAA and stuff, I think most of them are compute shaders.
Yeah, they're all compute shaders.
And
so again, that's really playing to the strengths of AMD's architecture, right?
Yeah, the thing about most of the FXAA, SMAA stuff is you're talking about like on high-res display, like a couple milliseconds or less. Like they are a small part of the overall graphics workload. So NVIDIA does that very well too. So I'm not sure that that's a big part of the total picture, but it is true that that's a nice way to take advantage of a GPU. And MSAA, because of all the deferred shading, rendering stuff that Unreal Engine and everybody else does, has not worked well for a while with most games. And we're finding that these post-process things, or sort of a combo of light MSA plus post-process, seems to be the right choice for a lot of games these days. And I have no problem with that. It's gotten good enough that it generally, like the best ones, SMAA is beautiful. So yeah. So okay, we're deep into Ris's single question.
Yeah,
it was a good way. It was a good way to kick off the architectural stuff.
There's one other point that I made last week that we made in the architectural discussion that, David, we should talk about just briefly. If we're talking about the matchup between Fury and 980 Ti, and why didn't AMD win when they had all that extra bandwidth? Because I asked Raja Kaduri, the graphics CTO at AMD, that question last week. And if you recall, his answer was about, basically he restated my question as, why didn't we build a bigger engine? Yeah. And the answer was that our chip was as big as it could be because it had to share an interposer for HBM. It had to share an interposer die with 4 stacks of HBM memory, and we're within like plus or minus 4 square millimeters, which is like you look at the pictures and it's like it's super tight tolerances. They built as big a chip as they could to go into that space, and so they invested in HBM. They made a big chip. They didn't invest in a more efficient new architecture, which is exactly what NVIDIA did, the opposite thing. Yeah. And NVIDIA stuck with GDDR5. And the end result is like different paths of innovation to something like parity when it comes down to like at least graphics rendering potential of these two things running current games. And, that's interesting. Because usually you don't take such divergent paths to get to a similar result. Usually they kind of track with each other more closely. And so that's kind of fascinating. It is the case that the way the game uses the GPU and the settings that you have will determine these things. And it appears that right now that the strength of the Fiji GPU and the Fury is the shader array. And the strength of Maxwell is geometry, texturing, ROPS, and like everything else but that. Not that it has a poor shade array, but it's not as good as Fiji's. Yeah. And so there's some very practical ways that NVIDIA seems to match up with the current usage model for games nicely.
Yeah, and I mean the other thing is that NVIDIA. I mean, one of the interesting questions that was posed to me was, well, okay, how much does the NVIDIA GameWorks program really matter? And that was, one of those things where, that's like a giant can of worms altogether that maybe it's best not to get into. But I think the key thing is that the results, it wasn't just like, oh, hey, AMD loses for GameWorks games and wins for everything else. It was actually, I think it was genuinely reflective of the state of affairs. And, certainly, obviously NVIDIA is not going out of their way to help any AMD GPU run fast.
Yeah, there is a big can of worms in the whole sort of question of GameWorks as middleware that NVIDIA provides to game developers.
Yeah,
and that's a little different from like developer relations generally. I think that there's a concern on the part of some folks at AMD that like there's a black box middleware, like you get a DLL as a game developer and no source code, and you call NVIDIA's software and then you get like a result out of it and you don't know why, or the performance is there, or you can't tune it. And NVIDIA's response has been, well, it doesn't really work that way. And I don't know. Like, I don't know how it works.
No, right. I mean, it's really simple. Like, look at the Unreal Engine. You get that is up on GitHub. Like, if you, I, or Jeff wanted to, we could get the source code for that. And that's something that, I don't know how much NVIDIA charges for licensing GameWorks stuff, but I guarantee you it's a lot less than the Unreal Engine is. And
they opened the source for the PhysX CPU stuff, right? When the GameWorks stuff when the Unreal Engine went free, I believe that the NVIDIA opened the source for, because the core physics engine in Unreal, I believe, is the CPU-based physics stuff. Anyway, this gets way down the path. I think that the question that I have is more about how much does NVIDIA's developer relations help with things like delivery performance in games, not necessarily but there's this whole aspect of like, is there dirty pool going on? That's a different thing, and I feel like I don't have enough information to get too deep into that. I will say that we had an interesting development this week around GameWorks. NVIDIA has been very active in promoting its DevRel stuff, and they do what's called co-marketing, where like a game's coming out, they have spent some time and effort helping to enhance this game for GeForce cards, for the PC, but really for GeForce cards, and they help like promote the fact that this has happened and that the game is coming out all over. They don't necessarily pay the developer money, but they provide services that have value in that form. And then, people will criticize them and they say, but look, GameWorks or our DevRel efforts, they help PC gaming, they help people have good experiences. That's what it's about at the end of the day, right? And we had something really quite different happen. Batman Arkham Knight is coming out, and I get an email from NVIDIA, and they're like, hey, this thing is loaded with GameWorks tech. We really want you to look at it. This is an awesome thing. This is, we've worked really hard with them on making this happen. Like, check it out, And they say, we got this particle effect, this physics effect. We got all these objects flying around in these scenes. There's a history with the Batman games where they've done this. And what happens
but the great thing is, since it only runs at 30 frames per second, you've got all the time in the world to look at each one.
Yeah, well, that's what happens is the game comes out and it's locked at 30 frames per second. It doesn't even maintain 30 frames per second on high-end hardware, even though, by all accounts, the game actually doesn't look that great. And I'll add to that I think it has some control issues, because I tried to drive the Batmobile, and the default control setup, it doesn't use the mouse for steering. It uses like keys with just analog input, digital input, like on off. You can't make all the turns, like impossible between 30 frames per second and that. It's poorly put together. And then there's a hubbub. PC gamers have finally had it. They're like, we're a huge market. We're powerful about that. We're going to make noise. And the first statement that we get out of the developer is, we're from Rocksteady, the developer. We are working with our external PC development partner to fix these problems, which means they outsource the port to some third party. And then there are all kinds of rumors about what happened there. The relevant point related to GameWorks that I wanted to make here is that NVIDIA sent engineers to put those effects in games. They worked with the company to do stuff with that game, and they did not have their priorities straight. because they didn't make sure that there was a good experience for people who own GeForce cards or people who have PCs generally before they put in the extras. And from my point of view, that's not a justification for, like, the justification for what they're doing needs to be that they're providing a good experience first and the extras come second. This shouldn't be about, like, competitive advantage for NVIDIA getting built into games. This should be about good experiences for end users getting built into games. And I think they've lost their way on their priorities when a game comes out. And at the end of the day, this is down to WB Interactive and Rocksteady more than NVIDIA. But if you're pushing and promoting and you've got all of this stuff that you said you'd done and you haven't, like, had a conversation with them, a heartfelt conversation about 30 FPS caps, like, what are you doing?
Yeah.
Like, this is not okay, you know? This is not okay. And I thought that NVIDIA was out there being an advocate. And their advocacy seems to be more for our special effects for our video cards than good experiences.
I don't see why that's surprising. I mean, you know, the thing is, like, you know, my instinctive reaction is when someone makes modifications to source code, you know, so that the whole world can see that, you know, that's the kind of thing that I'm willing to accept, that you're doing this to improve things overall.
Yeah.
Right? Because, you know, source code level changes, you know, first of all, anyone can, you know, any one of the developers at the development house can see them. You know, they're a little bit open to inspection, and you kind of know what's going on. And so, you know, the thing that really got me is that on some of the GameWorks stuff, you know, it's not readily malleable to the developers in the same way that Havoc is, that the Unreal Engine is. And that just sets off a red flag in my mind. And, you know, by the same token, like, I think it's totally great for NVIDIA to go ahead and show what kind of cool effects you can do on their GPUs.
Yeah.
You know, I look at this actually very similar to Intel's compiler, right? And we know in CPU land that Intel's compiler emits the best code for Intel CPUs. And they really don't go out of their way to tune for AMD CPUs. And there's a good reason for that, which is, you know, it's not to Intel's interest to make things run fast on AMD, but also they may not have the latest documentation. They may not know all the microarchitectural idiosyncrasies. So, you know, expecting NVIDIA to go out and maximally tune their code for a Radeon GPU is pretty silly. But by the same token, you know, when you start looking at things that are really just available to be linked in as a DLL and there's really no internal visibility, that raises red flags in my mind. And it starts looking a lot more like, you know, you remember back when, you know, the early versions of PhysX, and I remember we were talking, and you said, you know, each company has their own special blue sparkles, right? PhysX makes it a slightly sexier experience, and at the time, AMD had something else, and I can't remember what it was.
Right.
But, you know, everyone has something special like that. And
Yeah.
I think...
special sparkles are okay, but you need to keep your priorities straight. What I don't have good information on that you're sort of asserting is happening is exactly how developers receive and get to modify the code in this GameWorks program. There's been issues raised around it. There have been accusations from AMD about how it works. And I can't verify anybody's claims. I haven't had a developer come forward and give me a map to how it works for them.
Well, I bet, in truth, I bet it's flexible. Like, if you were, you know, look, if you're willing, if you're a big enough developer or you have a big enough checkbook, I bet that NVIDIA would be very happy to fork over source code.
Right. And see, that's the thing, though, is we just don't know. I'm uncomfortable criticizing on it from that point of view simply because I feel like I don't have all the information. But I think we can say they got their priorities wrong with Arkham Knight.
Yeah.
and anyway, let's go on. We've got a lot of questions, and we've now answered one.
Yeah.
Well, yeah, what's next on the list?
So
Okay,
yeah.
so this is simpler. So Selmore asks, do you think the GTX 980 and the GTX 980 Ti, I guess, will still drop in price in Europe? At least here in Germany, they didn't really drop.
Oh, you
And I
mean
think
in
it's probably-
response to the Fury?
Yeah, probably in response to the Fury X, and we should probably generalize this.
I don't know what
Not
the
Europe.
price is in relation to Fury. Is it more expensive to get the GeForce than the Radeon?
I mean,
Probably slightly more.
I don't know. Like the
I
question,
would think
the
that
assuming a price drop, I think you have to be assuming that they're getting undercut, or why would Nvidia drop prices?
well, I mean, there's also a question about supply, right? And you said earlier, Newegg's totally sold out of Furies.
Yeah,
Right.
And so and that's great for AMD, right? Obviously, the more they sell, the more profits they'll make. But, the question is, if they're somewhat capacity limited, then, NVIDIA may not really feel much, need to respond. I mean, and NVIDIA is a very astute company when it comes to business. They will not cut prices if they don't need to, just like any other company, right?
Yeah. The only reason that Nvidia would cut prices in a way that might seem a little irrational is just because they feel like they've got a competitor on the ropes, and if they can deny them some cash, then like they got 20 years of monopoly ahead of them. which that might be the logic at some point, but I don't know.
I doubt that thought has ever crossed Jensen's mind. He would never think something like that.
Yeah, he wouldn't. Okay. All right. Well, but I'm sorry we can't answer the question about Germany prices. I have no idea what's going on there. So.
Yeah. Give him a gold star for stumping the experts.
Yeah.
Okay, so Canon Air asks, and this is a long one. He says, this is less of a question about the Fury X and more of a question about graphics in general. I learned a long time ago that anti-aliasing, specifically multi-sampling performance, depends most on memory bandwidth and ROPS, but I don't really know exactly how it works or how it is affected by each of these factors. Would you be able to explain this a bit more in depth? And would the new delta compression on both Maxwell and Fiji help in the case of multi-sampling?
I don't think delta compression helps with multi-sampling except for just that it's a bandwidth optimization. So the extent that multi-sampling is bandwidth limited, then it could be helpful. But I don't think that it's a multi-sampling specific benefit. Now,
hold on.
Yeah.
1 sec. So the right way to think about this is think about it from a pipeline perspective. Okay. And, just correct me if I go astray here, but, the way multi-sampling works is, you're going to suck in a bunch of adjacent pixels. So that's where the memory bandwidth comes in. You pull them into the ROPS, into a small cache in there, and then you start performing some blending on them. So you're going to average nearby pixels and do things of that nature. And so that's the kind of like specialized compute that you get in the ROPS. And, a while back I could have told you what the actual equations were and what the operations were, but I seem to recall it being some sort of averaging and blending, and it's very similar to texturing in some respects, right?
Mm-hmm.
And so that's sort of where the compute side of things goes, and then you need to write it out. And the issue is that the more taps you have, the more pixels you need to suck in, and the more computations you need to do in the ROPS. So,
right.
When you think about it in that respect, that's kind of the idea of how it works, right? Is that about similar to your understanding, Scott?
Yeah.
Right. So that's the way you want to think about the bandwidth and the ROPS, and think about how many pixels you can stream out, right?
Right. And yeah, streaming out pixels is what compression helps with mostly. And
exactly.
You stream out the same number of pixels with or without multi-sampled AA.
Right.
So,
but it's how much bandwidth does it take, right? If you can cut that bandwidth in half, then you've got more memory controller accesses free for other things.
Right. So that's a big part of that. The ROPS are the hardware that does the blending of multiple samples in MSAA. So that's why they're the primary constraint, which is I think what you just kind of said. But just to clarify, that's why ROP performance matters for MSAA. I think that answers most of Canon Air's questions.
Yeah, Yep.
The other thing that you would say is that storing a lot of samples for multi-sampling is a storage. Multi-sampling is a storage intensive thing. If you have 16 samples per pixel, you have a lot of freaking samples, and you're stuck. Yeah. In some cases, there's been optimizations of MSAA like NVIDIA CSAA, where they store more coverage samples to place things, but then they don't store as many color samples in order to basically cut the storage requirements, but you still get more accurate blending. And that kind of thing is...
I would wager that's actually more of a bandwidth optimization in some ways, because, I mean, again, this goes back to like one of the big questions about Fury, which is 4 gigabytes enough? And the answer seems to be very clearly, unless you're doing something really, really special, and I mean like eating paint chips special, like 4 gigabytes is enough. So I would assume that, the CSAA and those things, the big benefit is on the bandwidth side.
Yeah, when I said storage, I actually meant storage bandwidth, not storage capacity. I'm sorry. I heard a really smart architect explain it and use the word storage to describe his CSAA. It was John Montrum at NVIDIA who came up with CSAA. He was one of the pioneers of AA techniques generally. And Montrum was talking about, I think it was him who was talking about it as a storage problem. Anyway, I hope Canon Air that helps a little. Multi-sampling is complicated, and you have to understand the graphics pipeline, and it's not something we could probably go into in any more depth tonight. But in terms of constraints, I think we kind of maybe mapped out where those things are and why that matters. And there are other pipeline reasons why, like MSA is turning out not to be the best solution in a lot of cases these days.
Yeah.
All right, so let's go on to the next question. Selmore asks again, do you think future aftermarket cards will have more often an all-in-one water cooler on them? I hope more NVIDIA board partners will go the way of EVGA's approach with the EVGA hybrid cooler, which is similar in principle to the Fury X.
Yeah, I think that they should. I think that it makes sense. I think that I want that option. I don't know that in every case that I want that to be like the default like it is here. But I sure like the idea that like somebody's out there offering that, because you think about the price of one of those coolers aftermarket, and you buy a card that already has a cooler on it, and you add that, you're adding a lot to the price. There's real value in just saying no, let's just delete the air cooler and make the water is cooler a default. And I could see myself buying a card with that type of cooler as my preference. So.
I mean, actually, and here's a thought. I mean, I wonder if anyone has looked at designing a single water cooler system that fans out heating blocks for both the CPU and GPU to a common
blower. Oh, yeah. PC enthusiasts do that all the time. Right? Yeah. It's just custom. And custom is like, then you're dealing with, you got to fill the system and deal with all the maintenance of the water cooling system. It's not an all-in-one. It's not a no maintenance thing. Yeah. But
that's no good.
Well, but a lot of people do it, and they build some beautiful systems. And if I had more time in my day, that would be what I would want to do. Right? That's the best of all worlds. If you get a big wide radiator, put a couple 120 mil fans on it, and just cool everything. Because the reality is, like, this GPU is, this video card is 275 watts, and it is a good choice in a lot of ways to pair it with like a Core i7 4790K. It's an 88 watt CPU.
Oh yeah.
And so if you're even going to water cool the CPU, which you may not even need to do, you really should be. The GPU is the one that needs that cooling more than anything. And so the situation right now where CPUs mostly get water cooling first and GPUs are a second sort of choice there is reverse of the needs of most systems. So, I could see that being a thing.
All right. So Egg Grenade asks, is there any word on overclocking the Fury?
This is another one of those cases where I didn't have enough time to do that. I had less than a week with this card, and it takes me a work day just to do our like graphs. It's insane. I didn't have time, but other reviewers are saying, what was it, like 100 megahertz or less that they were getting?
Yeah, I mean,
it's 10%.
It's
10%.
voltage locked apparently, and so you're not going to be able to like give it more juice to get the clock to go up, and so that was about it. And that's not entirely surprising because this is the highest end product. AMD said no overclocking or modifications of anything, and they're surely like the worst chips are getting binned out to go into the Furies instead of the Fury X's, and so like you already got what they have to offer, right?
I mean,
if they had more to offer, they'd be beating the 980 Ti.
I mean, the other thing is the best chips actually may be getting binned for the Nano. I don't know.
I think that's deeply unlikely because I think that will be a cheaper card. But, the Nano's fate in this whole thing is really kind of interesting. Now that we know that this is slower than a 980 Ti, the Nano has a much lower power envelope. It has just that cooler with one fan, right?
Yeah.
Will it be faster than a GTX 980? Because you can make a 980 that's the same size as the Nano. There are 970 cards, which is the same chip, that are already 6 inches. That are selling on Newegg now. Will the Nano be anything special in terms of performance and size when it comes out? It could be. There's a ton of parallelism in Fiji compared to GM204, but NVIDIA's been able to sustain high clock rates on the 204 and get pretty good performance in relatively small power envelopes. So I don't know. With the Nano's not here yet, and it's not a finished product. So this is all speculation, but I am a little like everybody says. Oh, that's interesting, right? The Nano is the one. It's interesting.
We'll have to wait and see, right?
Yeah, maybe it's interesting. Maybe it's like the same experience you already get from the existing cards in the 970. So
yeah.
Okay, so Power666 asks, what is the L2 cache size of Fiji, and how does it compare to Tonga and Hawaii?
It's 2 meg.
Yeah, 2 meg, twice Tonga.
Twice Hawaii, I believe.
Yeah.
Yeah.
That's right.
Okay, so here's a big, long one. Okay, so we're getting to the questions from the article comments now. So T-Bone8TY says, I'm just putting this out there. Here's a review that seems quite different from the other ones, and it's a link to a Russian review. And he says this one actually shows that the Fury beats the 980 Ti in a lot of tests, and even the Titan X in some tests. Of course, it seems in low resolutions, it seems that NVIDIA still wins a lot of times, but it's not as bad as it is with some other reviewers. Now, here's a possible reason why, he says. Driver version used in this review is 15.15-1806.12a.
You didn't have to read all that.
Yeah, whatever. Yeah. So he says that was sent by AMD on June 18th, and the press driver is a different version, I guess a less recent version, he thinks, and he says this is probably the reason for this inconsistency.
The idea being that like the Fury really is faster than the 980 Ti, but we all use the wrong driver.
Yeah, that's basically the implication of this statement.
I did use the driver that AMD provided to the press via the FTP site for our testing. Some people got confused because I said it was a Catalyst 15.15 beta, and they thought it was an old driver. That wouldn't work on the Fury, I'm pretty sure, but I didn't even try it. I used the one they provided. It's still a 15.15 beta, but then we could read all those numbers. But it's just a different string.
I think this bears like further investigation. I mean, if that's that would be like an epic fail on AMD's part, and I'd like to believe that they're not going to perform that sort of self-induced. They're not going to blow their feet off on purpose. But
here's the thing: they didn't, because what happened was I went and researched this a little bit, and one AMD rep, I guess, posted on Overclockers UK or something, and he said this is not. It's just basically BS. This statement that there's a different driver. Yeah, it's just it doesn't make any sense the way they presented it. So
you think it was a hoax?
It could be, or he said it could be a typo, but that's straight from the horse's mouth. So,
and I'll tell you, having been a GPU reviewer for many years, no company, if they think they'll give them a competitive advantage, will shy away from asking you to use a whole new driver at the very last minute for all of your testing. Like they both do this all the time. Like pain to me is nothing to them if they can win. So I seriously doubt that they would have like held back. Like we got more performance, but we don't want to ask. Like nobody does that. Like nobody's like, oh, but think of the reviewers. Like no, nobody ever does that. So just for what it's worth, there is a lot of potential for additional performance in AMD's drivers for Fury X, but the type of performance that they need is delivered performance in games with consistently low frame times. They don't need to win the FPS benchmarks. They need to provide a better experience for people. I'm not harping on that, but like, and if that driver exists and we don't have it, then that's a serious problem. If it's about FPS, again, 10% doesn't matter. Like it's not the thing.
Yeah.
So.
Okay. So Cougar asks, I have a specific concern about the Fury X. The internal shot of the card shows it's a GPU water block only. It does not cover any PWM/VRM circuitry. And the Fury X draws the same power as the 290X before. Overclocking or voltage tweaking is involved. You know, he's concerned. Basically, he's concerned that they're not adequately cooling all the non-GPU components.
Yeah, so like the rest of the power delivery network, so the VRMs and so forth.
Which you can see that in the picture here.
Yeah. So one thing I saw somewhere, so that little copper heat pipe that you can see sort of snaking around there, that actually runs on top of some of the power circuitry, I think. So it is getting cooled. I don't know. That may not be true.
But I'd have to maybe look at it again.
I mean, ultimately it's really hard to say because you'd have to figure out. I mean, it would be interesting if it turned out that, like, hey, this is the reason why you're only getting a 10% overclock. But without knowing a heck of a lot more about, like, what VRMs they're using and what the specifications are and what the junction temperature on those guys are, I don't know if there's any way to speculate. I mean, the one thing I'd, point out is that, I don't think on overclocking CPUs, are the VRMs cooled there? Like, I doubt it.
Well, sometimes you see motherboards with heat sinks on the VRMs. That's not uncommon. CPUs got weird when they integrated the voltage regulation stuff.
Well, there's still
some on the motherboard. Yeah,
still some on the motherboard.
But the other thing I'd say about it is that AMD has said that this thing can do that it's a 400 amp capable power delivery system and that it can do a lot, and that it only uses 250 amps in operation. So
no, that's not true.
That's what they told me.
Well, okay, so they may have told you that, but there's no way that's correct. I mean, if you have a 275 watt card, your instantaneous current draw can easily be 30% higher than what sort of the peak sustained is, right? And if you just look at like Intel's voltage regulators on their CPUs, it's really normal to have like for like 120 watt CPU to have like 120 amp CPU, you might have 150 amp supply. And, that's going to be true on GPUs as well. Because, if you think about it, right, what happens when you go from off to on and firing everything all at once? You have this huge current draw that's going to be way higher than that 275 because you have to go all the way from 0 to 275 and you actually have to overshoot to make sure you don't brown out. Mm-hmm. So, I would guess that for a 275 watt card, they probably only need maybe 350. But the other thing is, with PowerTune and a lot of the voltage and frequency scaling stuff that they have, you should not have to worry about exceeding the VRMs, right? And what will happen is it'll just maybe throttle the clocks when you're starting to pull at 400 amps. So, I mean, this is, a great question, right? We've got these overspecified VRMs, but the overclocking isn't impressive. What's going on, right? There's something there. that I don't know the answer to.
So you think that it's possible that the overspecified VRs they need, and then with overclocking, it's potentially not sufficient to add additional headroom?
Well, it depends how their power management works, right? Because, when the point that I was making is that the instantaneous power draw can be much higher than the sustained, but that's part of what DVFS handles, right? Like if you look at turbo mode on Intel CPUs and the equivalent technology on AMD GPUs and CPUs, the whole point is to enable the chip to gracefully handle those nasty spikes, and so that you can run the power supplied closer to the sustained power, right, to narrow the gap between the power delivery and the TDP. And so right here we have this scenario where you've kind of got a TDP that's about 275, but then your power delivery is 400. And yeah, you should be able to use that margin to overclock.
Okay. Even if you, well, the question is a thermal one. And instantaneous load doesn't matter a lot for thermals as long as
it doesn't at all.
And so, I don't know. We'll have to look at that. We can look at that with the. We may have to get in the Jeff. You may have to send me that IR camera that you ordered today, or I have to send you a Fury, which I know you. I know which one of those two you would prefer.
Yeah.
Which one has cheaper shipping?
I also know which one of those two I would prefer, but one way or the other, we might take a look at that and see. It's possible that there's a problem here. One would hope that AMD's board guys didn't get this wrong. So we'll have to see. Let's move on. The next question is.
So this is not Fury X related. But let's tackle it. So Narwhale AU asks, or he says, I game on a 30-inch monitor. It's a 2560 by 1600 monitor. I guess he has a Radeon HD 6950 from about 5 years ago.
Yep.
He says, I'm looking for a new card in preparation for XCOM 2, Star Wars Battlefront, Mass Effect Andromeda, and Fallout 3 with a bunch of mods. He says he can stretch up to the Fury or the 980 Ti, but would something like a 290 or R9 290 around $250 be a better deal? If you get the $650 card, you'd keep it for 5 years. You get the 290, upgrade in 2 to 3 years. It should be right around the time he's looking for a 32-inch monitor. So what for 2560 by 1600, like what are we talking? Is the Fury overkill for that, or?
I think the best value right now for 2560 by 1600 gaming in terms of GPU price is the GeForce GTX 970. I think that's the best combination. It's $336. It's got GM204 with the latest stuff. It's slightly cut down from the 980, but not a lot. And in our test, the Fury X was slower in games than the 980 at 4K. And by all accounts, the competitive situation is less good at lower resolutions. So I don't think for that situation the Fury would make sense. The R9 290 draws about 100 watts more at the wall socket than a GTX 970, I think, off the top of my head. That goes into the case, and you've got to remove it. So I think that probably the 970 is the best deal right now. The other thing is a strategic question. And David, you're like this. The strategic question is spend a lot now or spend a little now and then spend again sooner. And because of Moore's Law, generally speaking, the answer is spend less now and then spend again sooner, because power of GPU is constantly going up. I'll sort of double down on that and say we are into like the fourth generation of 28 nanometer like rebrands plus a few new things. Although we did, to NVIDIA's credit, they did a whole new architecture with Maxwell. But 16 nanometers from TSMC is hopefully eventually soon going to like produce GPUs that are not only like 2 generations of process technology denser than the 28 nanometer stuff.
No. 1 generation denser.
Is it really? Well, 20 and then the 16. I mean, their density
of 16 and 20 is the same.
Yeah, their density hasn't been getting better. Okay, but they're also going to FinFETs, which should be great for power, right? So that's happening, and my expectation is that, honestly, I think that HBM, which AMD built in the Fury X, I think it was probably originally targeted to go along with the 16-nanometer GPU, but we had delays on that stuff. I could be wrong, but I think, I don't think originally the plan was to build the first HBM stuff alongside the 28-nanometer chip. I could be wrong.
Oh, no, I agree with that. I think...
And the new process tech is coming along with HBM2.
Yeah, I mean...
doesn't that give you more than Moore's Law progression in the next little while as long as everybody executes?
Yeah. I mean, so the way I would put it is, first of all, I think that originally AMD was betting that TSMC's 20-nanometer would be good. And it turned out to suck.
Yeah.
That was no good.
Yeah.
But, I mean, the way I look at it is, and I'm actually not too far away. Like, I have a 6970 in my rig with a 25 by 16 monitor. And, I'm perfectly happy, although I don't game a whole lot. But
that's why you're happy.
Yes. Lots of Excel spreadsheets.
Otherwise.
But, the way I look at it is 16 is going to be a huge improvement over 28. And AMD is going to have a new architecture for 16. NVIDIA will have a new architecture. NVIDIA will have HBM2, and so will AMD. So, when I look at what we're going to see, I think it's going to be a really, really big step function. So I would say definitely hold off till 16 nanometer if you can, especially, I was looking at the comments in the thread, and some of those games aren't coming out to the end of this year. And so, I don't expect... maybe at the end of this year we'll see 16-nanometer GPUs. I'm a little skeptical, but certainly in a relevant time frame, you'll be getting 16-nanometer GPUs, and that just seems like a better bet.
Yeah, between 16-nanometer and what's happening on the memory side with HBM stuff, I think it's going to be awesome in the next.
Oh yeah,
yeah, and so I wouldn't want to miss that. If you have $650 to spend now. Spend $336 on a 970. Put the rest into a CD that bears a nice interest rate.
Hold on. What about contributing to Tech Report? I mean, we're helping him out. He should become a gold subscriber.
When you're at the end of the process, when you're happy, sell that 970 after you've upgraded, and then give the proceeds to us. That's there we go. How's that? So, but yeah, I mean, I would not spend a bunch of money now if you're thinking about a long-term plan. I also think that your long-term plan, if you're a PC gamer, should involve a variable refresh display and not continuing to use a 60 hertz. As I sit here and stare at a 60 hertz monitor talking to you, the ones I use for gaming are 144 hertz variable refresh, and it is a beautiful thing. Don't miss out on that. And in fact, if you're thinking about your budget, you may need to start thinking about including a display. It's a bigger upgrade, assuming your GPU can do it, to get a variable refresh display than to just go to another generation of GPU and still have display quantization at 60 hertz.
But by the way, does the variable frame rate help at all in like standard 2D like Office applications at all?
No, but they're high refresh. So everything you do, like dragging a window across the screen with the Explorer window on the desktop, is smoother in a 144 hertz display. Scrolling text and being able to read it as it goes by is better. Nice. And if you have a fast gaming display that doesn't have a lot of ghosting, then it's crisp as it goes, right? Scrolling a page in the web browser, you can read as it scrolls. Like,
I'd say definitely get yourself the big 32-inch 4K display and, high frame rate. Sweet. I think people spend a lot less on monitors than they should in a lot of cases.
Yep. And it turns out that variable refresh displays help overcome, fixing the display quantization is a bigger effect than you would think, because it sort of helps patch over. You don't realize how much of what you attribute to GPU performance pitfalls is actually just display quantization. Once you get rid of that, you don't need as much GPU as you think to have a smooth gaming experience. I think you can play most games on a GeForce GTX 960 like a $200 card, or like R9 285 at 2560 by 1440 if you have variable refresh. And this is right now the current state of things, and it's maybe a better experience than spending another $100 on your GPU and sticking with the fixed refresh rate. So, yeah. Okay, moving on.
Okay, so so there were multiple parts to this. We got the one about like process shrinks. He says, with the Fury X, do you think the Fury X is a case where the drivers will likely improve over time and it'll look like a better and better deal? You know, in 6 months, will this look like a great card that just suffered early driver issues? Can we say? I mean,
well, look, I mean, in my review, we showed that in practical terms, in real games today, the Fury X performs less well at 4K than a $150 cheaper GeForce GTX 980. I think that software improvements can fix that problem by and large. Yeah. I could be wrong. There could be architectural reasons why GCM-based GPUs occasionally have performance pitfalls, but it doesn't seem right that they would have performance pitfalls that would affect entire frame times like that. It's a big scale problem to be a GPU architecture problem. Assuming it's software, they could fix it at any time. And assuming it's software, they could have fixed it at any time from the release of the first GCN GPU in late 2011 to now. And not only that, you'll recall that when we were testing frame times first, and there was that Christmas where AMD had a bunch of Gaming Evolved games coming out, Hitman Absolution, or whatever the Hitman thing was, Sleeping Dogs. They had all these things in the Never Settle pack, you know, that was bundled with the card, and they had all of this goodness. We tested those games expecting AMD to win, and when we did frame time testing, they had problems that NVIDIA didn't. NVIDIA was doing a better job with its drivers at that time. They fought us about that, and we released a slow motion video showing the problem, not just in numbers, but in a visual form. And then the conversation changed, and they went and worked on their drivers. I think it was the Catalyst 13.3 betas. They improved substantially frame times compared to what they had before. They were motivated, and they did it.
Yeah.
They have not since then consistently done that work well, and we have documented that over time. Will they change? I don't know. Could they change? Yes. How likely is it? I don't know. I wouldn't count on it, right? I wouldn't count on it. And could they get another 10% and win the FPS race? Yes. Can they provide as good a performance to the end user as their competition? That's harder. And they've shown us nothing that makes me think they're committed to doing so. I hate to say that because it's entirely possible they're working on something now, and like the Windows 10 comes out and the DirectX 12 stuff and all that, and they're winning on drivers. But no one has said anything to us to give us that indication that actually that kind of optimization work has happened.
Yeah, I mean, I think the big takeaway there is, you know, there's a lot of strategic issues there, and one is we're talking about DX11, and I think for most people, DX12 is the future. And so being at AMD, and this is not to say negative things about them at all, but if I was in charge of this problem, my answer to the problem would be, well, thank goodness all the engines are porting over to DX12. Windows 10 is going to be out in, you know, a month. That'll eliminate most of our driver problems right then and there. You know, that'll equalize things. So does it really make a huge amount of sense to invest a lot of money and a lot of effort in a company that doesn't have a lot of money to try to fix this now, or do we really just focus on making things great on Windows 10?
Yeah, the issue there is that optimizing now for DX12 on Windows 10 is optimizing for the 3 years in the future of gaming. There will be some demos and early things that use DX12, but we just talked about how people are still testing on Skyrim because it's still a game that people like and play. The reality is that it takes 3 to 4 years to build a AAA title. And that's the lifespan of a Fury X GPU. That's maybe longer than the lifespan of it. In fact, that's how long it takes to build a GPU. It doesn't work to optimize for DirectX 12 and ignore everything that's in development now and everything that's sold up to this date alone and expect to win. You may be completely right, David, that may be the choice that they made. But I'm just trying to talk about what the impact of that choice happens to be. And the impact it's difficult. Like, that's not a good impact.
I mean,
right?
I'm just saying, like, in general, I wouldn't buy a GPU or a complex system on the basis of the software will improve in the future, right? And
right.
Yeah,
because
absolutely.
I've heard that one, right? I've heard that one before from NVIDIA. I've heard it from Intel. I've heard it from AMD, and from Apple too, right? I mean, I think at some point when I was younger, I used to compare iTunes to a case of secondary syphilis. Right. Once that shit gets in your spinal cord, you go crazy like Nietzsche, and it's all downhill from there. And now I'm sure iTunes is probably okay, but it was years before I'd even touch it with a 10-foot pole.
I guess it got better with like the last version when they changed the interface and stuff. But maybe it's just because I can't find things anymore, so I'm not frustrated trying to do stuff. I just give up. I don't know, man. I don't freaking like iTunes for Windows, but
yeah, abomination.
Right now that we have iCloud, like I don't need it for my phone, and so
exactly.
it's okay. So they solved that problem, but they didn't solve it by making iTunes software right. They solved it by we'll just bypass that completely.
Yep.
So yeah. Anyway, okay. Do we have other reader questions?
Yeah, we have one more question. So someone asks, I forget now. I'm sorry to the anonymous questioner, but they say, do you think when 16 nanometer hits for GPUs, will we still be stuck on that for longer than 28 nanometers was around?
I don't know, man. It gets harder with every generation, right?
Right.
Oh,
yeah,
but 28 was an amazingly long run, so it's it's depressing to think that it would be that long. But Dave, tell us give us go on record with our prediction here.
I think that here's the deal. TSMC and Samsung and Global Foundries have much more difficulty ramping things into high volume than Intel does, period. That's just been the case forever. Mm-hmm. And, part of that is that Global Foundries is formerly AMD, formerly IBM, is not really high volume. And TSMC, sometimes they get their shit together and it works, and sometimes they don't. 20 nanometer, they did not. There is today no large 20 nanometer chips that ship, period, except FPGAs, and those are a special case. And I think this is a testament to the fact that things are getting way harder. And I think with 16, they might. So the thing about 16 nanometer is it's using 20 nanometer metal. So the interconnects are 20 nanometer class, but then it's a 16 nanometer FinFET. And so, the question is, can they shrink that down to 10 nanometers in a hurry? And, I got to say, I'm not all that optimistic. Because to go to finer pitch metal layers, they'll need to do more multi-patterning. That blows up cost. To go to 10 nanometer, they're going to need to shrink. Essentially to get to 10 nanometer, they will have to do effectively 2 nodes worth of shrinking the metal and 1 node of shrinking the FinFET. And, for a bunch of companies where they're having a lot of problems bringing out FinFETs, period, with the same metal interconnects that they already had supposedly right. I mean, I think you're asking for a lot.
Yeah.
And, if they can make that work, then I would like to know what stocks to invest in next and the winning lottery in California.
Right. I want to win the lottery in a state with no income tax, but to each his own.
Any lottery would solve my, I could buy a house.
Okay. Yeah. I get it. It does seem dire for like Moore's Law generally, not just because of the practical pacing that we're seeing here, and the fact that there are these price issues involved and stuff. Like being able to do something and being able to do something at a cost-effective fashion are two different things, and those differences are starting to matter a lot when it comes to who builds what chips and what processes get pushed ahead. And
Yeah.
It's hard. It's been hard for a while. There was rumor today that Intel is pushing back 10.
Mm-hmm.
What's happening? Are they pushing back 10?
I don't know. I mean, but I think the key point here is, I don't expect things to get easier in the future. And if Intel thinks they might have to slip 10 nanometer, and TSMC tells me that their 10 nanometer is on time, it's not really credible.
But you think there's some?
I don't see it happening.
You think there may be some significant innovations in Intel's 10 nanometer that we wouldn't probably see out of the foundry guys, right?
Yeah, I mean, right. So we talked about this before. I think they're, more likely doing some sort of silicon germanium or germanium for PFETs. But, I don't think Intel has material sciences problems. They haven't. That has been an issue.
Right.
I mean, it's, to me, I think the problems afflict everyone, and it's issues around multi-patterning and just generally cost escalation. And the thing is, Intel's much more insulated from that than anyone else, right? If you look at how many dollars per millimeter squared of silicon, Intel's way better off than the GPU guys. So, they can afford it. Yeah. Did we have any other good questions in the live stream chat?
I'll open a call for any more. My list is pretty much empty, save for one, which we'll get to in a sec. But
okay.
Oh, okay.
So, any questions? Ask now or forever hold your peace.
Yeah.
That's right.
Let's see what the chat produces here. So, should we address this one question we have outside?
Yeah, sure. Okay.
Yeah,
so
and then yeah.
Okay, so Scott, this one is for you. Milo Burke asks, "Are you going to be at the Tech Report barbecue?"
Yeah, I haven't committed to that this year in writing on the site, and that's not really actually a coincidence at all. I don't know. I haven't made formal plans. I always go. I have gone every year. I expect I'll go, but I've been too busy with Fury and stuff to sit down and think about the future. I don't. I'm going to drop dead of a heart attack between now and then, just working on GPU stuff, and so I'm not planning that far in advance. I'd like to get out there. I've gone every year for 3-4 years at least, and it's been great. And we generally bring a carload of stuff to give away, and try to get some sponsors to kick in some hardware and stuff to make this fun for everybody. My intention is to go, but I literally haven't had time to sit down and plan. I will drive up there at this point. So I need to look at it. One complication is I think it's the 15th of August this year. Yeah. If you're not familiar, guys, this is in Holland, Michigan, on the eastern shore of Lake Michigan. It's sandy beach, beautiful setting, beach house by one of our, owned by the family of one of our forum members he's opened it up multiple times. We've had large numbers of people. It's a family event, so that lots of people come, and we do fireworks, and we have barbecue, we cook out, we play yard games, we have contests, swap meet with old hardware, and just talk about geeky stuff all night, or all day into the night, fireworks at night. It's a great event, and if you can, you want to make it out there. It's a ton of fun, and I believe it's August 15th this year, and that's a little late. I was hoping to maybe take the whole family, but my kids have school starting, and the ritual around the beginning of school is a thing that also takes time, and so I'm not sure how that's going to look in terms of me going, and also bringing Gyromancer, who's in the chat, who's my son, who does a lot of our chat moderation during the podcast, who has been to the past podcasts or barbecues. So I'll probably post something on the site when I have my plans solidified. So there you go.
I'm going.
I definitely won't be there. So Hot Chips is the day.
So because what? Hot Chips
is on, I believe, that week, and then it's a crazy busy week. So it's Hot Chips is I think August 16th or something, and then IDF is the week after. So we've got back-to-back tech conferences, and we'll definitely be seeing some interesting stuff at both.
Man, yeah. So I'll have to go. IDF is early this year. I may have to fly from Michigan to San Francisco. Okay. We'll see. See, that's why I haven't planned this thing yet. So we'll have to see what happens. But I there's probably a way to make it go. So do we have other questions from the chat?
We talked about Fury X overclocking, like it's voltage limited right now, I guess is the answer. Let's see if there's anything else. Someone asked, which aftermarket GTX 980 Ti do you like the best? It's the gigabyte so far that you've handled? They're
sitting back there. I haven't really tested.
Okay.
So I need to finish that work. I can't tell you which one I like best now. I mean, I held them in my hands, but I haven't done anything with them. So there will be an article to answering that question. So,
all right. Well, I think that's it. I think we should probably wrap up there.
Okay. Well,
good deal.
Excellent, David. Thank you for joining us.
Yeah.
Appreciate
it. Thanks very much, David.
And thanks.
Another successful conclusion.
Yeah. Thanks to everybody in the chat who joined us, and for all the folks who had questions. And we'll try to keep this going. Hopefully, we can do this again soon with David.
Yeah.
So, okay. Right. Take care, everybody.